Okay, hi. We're going to try to use Packet Tracer here to develop a small network. This is a smaller version of the requirements for your project. This program is Packet Tracer. I'll put a link out on Moodle so you can download it and install it at home, and also in any of the labs that it might be required in. So you should be able to see under Start, and I haven't even looked here, all programs, but we should see Packet Tracer here someplace, and Packet Tracer, Cisco Packet Tracer. And then you just go ahead and run Cisco Packet Tracer at that point within that Start menu. Okay, so what we're going to do is start by building a small network. 2 LANs. We're going to go to end devices, which are PCs, and all you have to do is click and drag it up. Drag it up onto the screen. You notice it says PC 0. Now, if you scroll over it and just leave your cursor on it for a second, it'll tell you what the IP address is, the gateway, and all those particular settings. We don't have any just yet. Now we'll need to go to switches, and I'm just going to choose a generic switch. And now keep in mind I grabbed this one right next to the 2960 switch. So it's just a generic switch. Okay, now a router. I'm going to grab this generic router as well and put that right there. Okay, now I'm going to do the very same thing for the other side. We'll build 2 small local area networks. And notice it says PC1. So on this side, this is local area network 0 or LAN 0, 0, switch 0, router 0. I'm going to grab another and just click and hold and drag generic switch. Come over here, grab a generic router. Okay. What we do next is tie those together with cables. So when you go to connections, the black cable is actually the UTP cable that we'll use and that we talked about. So I just click on the cable, click on my first device, choose Fast Ethernet. That's the only Ethernet port on that box, similar to a PC. Click on your switch, and I'm just going to choose the first connection, Fast Ethernet 01. The next connection will be from the switch, Fast Ethernet 11. Notice it was incremented to the router. Now on the router, because it's a LAN connection, I need to go to Fast Ethernet 00 port. So remember that. On the other side, I'll do the same thing. Come out here, Fast Ethernet to Fast Ethernet 01. Come up here to Fast Ethernet 11 and go to Fast Ethernet 00. Now the first thing that we'll do, and I'm going to bring this up, and you can download this. So step 1, build the LAN 0, and we've actually done step 1 and step 3. Now, on step 2, we're going to apply the IP addresses. So I'm going to take a few seconds to type in some of this information as we go. So the IP address will be 192.168.0.2 with a subnet mask of 255.255.255.0. What that means is that last number, that last number being 0, means that only this part of the IP address will be the host, and that this part of the subnet mask says that this part of your IP address is the network address. The gateway will be 192.168.0.1, and the network ID is 192.168.0.0. Now the gateway refers to this point where your local area network actually hits that router. So maybe I'll just leave that as is, and we can refer back to this. I'll start entering those IP addresses. So basically on this side we're using 192.168 addresses. On the other side we're going to use 10.0.0.2 for the IP address. The same subnet mask, which says that this is the host address. The gateway will be .1. The network ID is 10.0.0.0. On the router itself, we'll put 10.0.0.1 here. That's the gateway, and then use the same subnet mask. So 192, if I remember right, you click on the box. Well, if I remember the IP addresses correctly, this will go fairly smoothly. To configure the box, you click on the PC, go to Configure. Now, what we see under Settings is the gateway for PC 0, and that was 192.168.0.1. That's all we need to put in. That tells this computer the path out. Okay, under the interface, Fast Ethernet, I'm going to make that a little bigger. First of all, the port status is on. That's good, and we see that from the green light here. Now, we're going to put in static IP addresses, and the first address is 192.168.0.2. Now, because we're using a 192 number, this particular subnet mask is going to default out to 255.255.255.0. So we should have this particular box configured. We don't have to configure the switch with IP addresses. We can if we want to. We don't have to. We're not going to. Now on the router itself, we're going to configure. And let's take a look at the settings. And routing, we'll set that up. But Fast Ethernet 00, we want to turn that port status on. And the IP address will be 192.168.0.1. And then the subnet mask will fill in with the default. Now notice when I change that IP address, the green light comes on. It's going to take a little while, as is a real-life environment, for this particular port to be activated, for it to turn on. So I'm going to close this. There it turns on. Okay. Now, at this point in time, let's verify connectivity from here, from the PC0 to the router. I'm going to click back on this, go to Desktop, go to Command Prompt, just like you would see on your own desktop, and ping is a basic connectivity function. Basically what I'm saying is are you there? And it's replying with yes, or if it's not there, it doesn't. So ping 192.168.0.2. That's the IP address of itself. I can test for functionality, okay, and connectivity. So my PC's TCP/IP stack is working correctly. Up arrow, and I'll go to 192.168.0.1, and that is calling out to this particular point on the router, and it's replying. Now, let's see what happens if I put in an IP address that doesn't work. 192.168.0.3. There is no IP address in this configuration that is .3. And what you'll see ping do is just kind of hang out and not reply in any way, or request timed out. Okay. We'll Control-C and quit that. I'm going to close this. Let's go and configure this side now, and I'm going to drag that down just a little bit so we can see the green switches here, or the green lights. Remember, configure settings. The gateway on this side was on PC1. The gateway is 10.0.0.1. So the step 4 applies to the right network. So we'll go back to here. Whoops, we'll go back to there. And that is 10.0.0.1. The interface, a fast Ethernet card, drag that out. The port status is on. The IP address is 10.0.0.2. Now the subnet mask, look at that, defaults out to 255.0.0.0. We have to go in and change it physically to 255.255.255.0. The number 10 implies a Class A IP address, and by the nature of a Class A IP address, only the first number is the network address, and the last 3 are host addresses. We want to make this so that only the last number is the host address. And mostly, not that it wouldn't work, but mostly just to try to keep it simple. That's our goal. We'll close this. We'll click on the router, go to configuration, settings, fast Ethernet 00. We'll turn the port on. Notice it turned green. Now our IP address is 10.0.0.1. That's the IP address of that port. And then of course the subnet mask is going to default out to a Class A generic subnet mask, 255.255.0. So we will change that and we'll close that. Now, we'll have to wait a little bit here for that to turn on. We're going to go back in from PC1 and verify connectivity. It's turned on, and I'm going to ping, P-I-N-G, 10.0.0.2. That's the IP address of PC1. And 1, and we get a reply. Okay, so that side is working. Now we need to connect the two together. What we have to do is now put a serial line in between two routers. That's the standard configuration. UTP from the router out to your local area network, and serial lines between the two. And you have to choose the one with the clock on it. The clock rate, one of these routers has to know what the clock rate is. So we can go from serial 20, and we're going to go serial 20 on both sides. Now, on router 1, or router 0 I should say, we need to go to the configuration for the interface serial 20, turn the port on, and set the clock rate at 80,000. For us, it's not going to matter what particular clock rate it is. It just needs to be turned on. Okay. Now, on this side, we have to go back to serial 20 and turn the port on as well. Okay. Now, one thing I didn't do just yet, on serial 20, we still have to configure this. So when we configure it, let's take a look. Step 5, build connecting network. And that's what this piece is of the connecting network. So router 0, and actually, just to be clear, I'm going to go and add a text box that says connecting network. And drag that down there just so we can be clear what we're talking about. Also, this is LAN 0 on that side. Drag it down there. And I'm clicking on that text box, so you can do that as well if you want to make comments. And it's not a bad idea to actually make comments on stuff like this, just so you can easily refer back to it. Now, we were at adding IP addresses, and under your packet tracer steps that's out there on Moodle, router 0, SE20, which is this port, is going to be 200.0.0.1. Again, a subnet mask, 255.255.255.0, and the network is 200.0.0.0. On router 1, on this side, the IP address is going to be 200.0.0.2 on SE0 with the same information for subnet mask and network. So we'll go to here. IP address is 200.0.0.1. And that subnet mask, because it's a Class C network range, defaults out to 255.255.255.0. I'm going to turn this off. Go into this one, go into serial 20. It's turned on. Now, we don't have to set the clock rate because it's on the second side, the back side. Only the front side, or the first part, needs to be turned, the clock rate needs to be turned on. So this is 200.0.0.2, and that's the default IP address. Okay, so we've got that. Now let's go back to go back to this text file. Step 6, add the routing protocol to both routers. So what has to happen is there's a connection between here, or disconnect, let's say, between this point, at this point. This side of the network, I should probably rephrase that just a little bit. Anything past this router creates a disconnect. Anything on the LAN 1 side, anything past here creates a disconnect. Now, I'm going to go back to this PC just to demonstrate this. Command prompt. Now, ping. Recall that this point on LAN 0 is 192.168.0.0. 1. We can get a reply. Now we want to see if we have connectivity to the other side of the router. So we're going to ping 200.0.0.1. And we do have the router. Remember, I mentioned that there is a disconnect if you don't create a routing protocol. There's a disconnect at this point. Now the next step is we'll try 200.0.0.2 and try to ping that. Now remember, 200.0.0.2 is over at this point. This means that what we're going to need to do is add a routing protocol that can send the packets, or better yet, add a routing protocol telling this PC how to find this network. And then vice versa, we need to add a routing protocol on this side so that this PC can route information through this router to this network. Okay, so hopefully that was clear as mud. To add a routing protocol, let's go back to this. Step 6. Add the RIP routing protocol. Add both network addresses to router 0, because router 0 sees the 192.168.0.0 on this side, and it sees the 200.0.0.0 on this side. Okay, router 1 sees the 10 space on this side and the 200 on this side. So as long as this can get to here, this router can then tell a packet or a ping from this box, from PC1, how to get to PC0. Now that's the goal, that's the hope. Okay, so let's go back to router 0, routing, RIP. The network we need to add is 192.168.0.0. Add that. We need to also add 200.0.0.0. Those are the two connecting networks for router 0. We'll close that. Go to router 1, go to RIP, and add, it sees 10.0.0.0. Add this. It also sees 200.0.0.0 as well. And the 200 again is this network, the connecting network, and the 10 is this local area network. So we'll add that and we'll close it. Okay, now you see our connectivity, our green lights are all over the place. So we want to test this, and hopefully I haven't messed up. Sometimes there's enough numbers here, enough IP addresses and enough settings. When I go through this quickly, I may miss some number, some setting. Things look pretty good because we have green lights all across. So I'm going to go back to PC1 and test connectivity. Under this packet tracer steps file, test connectivity. So starting at PC0, ping each network connection, verify the reply. If everything is verified there, go to PC1 and do the whole thing backwards, just to verify all your connectivity. So we'll go here to command prompt. Now ping our first spot, which we verified already, we'll do it quickly again, is this point, 192.168.0.1. Okay, we're good there. The next IP address to hit, 200.0.0.1, is right here. Now remember, this is the point we had to disconnect. We're going to go to 200.0.0.2. And we have a connect. We actually have a reply, and that's from this point, the right side of this connecting network. Now let's go ahead and jump over into LAN 1 to this spot. That was 10. And test the connectivity over there. 10.0.0.1, I think. And then we have a reply from this side of the network. And 2 is the actual PC. Okay, great. Now we're going to go to the other side And this is more just a practice and verification. Ping, we're going to start at this spot, 10.0.0. We didn't do that right. About 1. Okay, a reply. Quickly, 200.0.0.2. That's the right side of the connecting network. A reply. So 1 is the left side of the connecting network. Now we're across routers. The next spot is down on LAN 0 at this point, 192.0.0.1. And then finally, 2. Okay, so that works. So that means our small network actually works. That means if we sent a web request, an HTTP request, from this box to this box, it would receive it and work. The ICMP messaging protocol, it tests the TCP/IP connection. Now, if you have an application error, that's another matter. But as far as basic connectivity at the TCP/IP level, the router level, or level 3, which are all synonymous, that proves we have connectivity across our network. So, okay, so hopefully that helps.